A look at dividing radicals. So here are some examples, and I have the square root of 1/9, or radical 1/9. The entire fraction is inside the radical, so what we can do is we can take the radical and we can break it up, and you can have the square root of the numerator over the square root of the denominator. At this point, you know the square root of 1 is 1, and you know the square root of 9 is 3. And we can simplify that down to 1/3. Gets rid of the radical completely. The next one here, let's again split it up, and we have the square root of the numerator over the square root of the denominator. Square root of 7, we can't do. It's already simplified as much as it can be. You do know the square root of 16 is 4. And that is simplified. Okay. Number 3. Number 3, we're going to do a couple different ways. So let's remember that when we multiply fractions, you can multiply the outside numbers and you can multiply the inside numbers. We can do the same when it comes to dividing. We can divide outside numbers and divide inside numbers. A lot of times, instead of saying dividing, I will say reduce, because we can reduce both of these numbers by 2. It's the same as dividing by 2. So I'll kind of flip-flop probably back and forth between the terminology, but it's all the same. So if we wanted to simplify before we do any kind of work with the radicals, then simplify your outside numbers. Well, we can't. It's just 7. And if you divide or simplify or reduce these inside numbers, 2 goes into both. So now this becomes the square root of 1, which, you know, the square root of 1 is 1. And this becomes a 9 when you divide by 2. And the square root of 9 will become 3. 7 times 3 is 21. So this final answer is 21. That is one way that we can solve that problem. What if you decided, when you look at this, you didn't see the reducing here, and what if you thought, well, radical 18, and you do that real quick in your head because you're kind of conditioned now to do radical 18, and you say, okay, well, that's 9 times 2, square root of 9, so 3 radical 2. Well, if you said 7 times, and then you turn that into 3 radical 2, see how 18 became the 3 radical 2? Then we can keep the denominator the same. Well, now you can cancel these radical 2's, and 7 times 3 is 21. So yeah, you're going to get the same answer as long as you can legally do the math that you are doing. So it really doesn't matter if you simplify the fraction first or the radical. As long as you do all of the steps in the end and continue simplifying to the very end. Let's move on to number 4. Number 4 kind of has a lot going on. So this one, I would definitely, I always try to simplify outside numbers, inside numbers, because I like to reduce my fraction as much as I can before doing any heavy math. So if I reduce these outside numbers, that's what that looks like. It becomes a 2 over 1. Reduce the inside numbers, then that becomes a square root of 7 over the square root of 1. So this would actually look like 2 times the square root of 7 over 1 outside times the square root of 1. Well, my numerator can't do much with that. That's 2 radical 7. Your denominator is 1 times the square root of 1. Well, the square root of 1 is 1. 1 times 1 is 1. So it's all of this over 1, which doesn't really matter. So that's just going to be 2 radical 7. And that's your answer, 2 radical 7. Number 5, I'm going to try a couple different ways. First thing I'm going to do is I'm going to reduce outside numbers, done, and reduce the inside numbers. So I'm going to reduce 40 and 5, both by 5. That's a 1, and that's an 8. This becomes square root of 8 all over 2 times the square root of 1. It's just 2. Radical 8 we can simplify. Can you do radical 8 quickly in your head? There it is. So we always have to continue simplifying down as much as we can. Radical 8 is not simplified. Keep going. And then once you're almost done, see if you can simplify any more outside, inside. And this can be done. And this will simply turn into radical 2. That's one way we can do this one. Some of us looking at this might be like, wait, radical 40, I can do that. It's 4 times 10, square root of 4. So you might want to rewrite that numerator as 2 radical 10. And it is. 40 is equal to 2 radical 10. Your denominator is 2 radical 5. Well, at this point, now you would simplify your outside numbers, cancel, and you would simplify your inside numbers, divide by 5, and when you divide by 5, your numerator becomes radical 2. And this, of course, is the square root of 1, goes away, and now see how we get the same thing? So you can do it either way you want to. Simplify first, and then you'll have to continue doing your radical and simplifying, or you can do your radical and then simplify after. Either way. Okay, but here's the big thing about radicals. You cannot have radicals in the denominator. It's not considered simplified. All of these problems that we already did started with radicals in the denominator, even though it's kind of a great big fraction. No radicals in the denominator can happen. There's a radical 5 and a radical 3 in your final answer. The first 5 problems we did, the radicals happen to cancel out nicely because we wrote them that way, but what if they don't cancel out nicely? Then we need to rationalize the denominator. So we will need to rationalize the denominator when they don't cancel nicely. So let's take a look at this one over here, number 1. So for down here, this is a radical 2. I can't cancel it with anything in the numerator, so this is how I get rid of the radicals in the denominator. I am going to multiply it by itself in the denominator. So I'm going to put a fraction bar there. When I multiply it by itself, radical 2 times radical 2, remember you can multiply inside radicals, that's the square root of 4. And the square root of 4 is simply 2. Well, that's great. I got rid of the radical in the denominator, but I just can't do this unless I multiply the numerator also by radical 2. When I multiply my original fraction times radical 2 over radical 2, remember this number here, if you are to simplify it, it's equal to 1. You're multiplying something times the number 1. Okay, it doesn't look like 1, but whenever you multiply a number by what's essentially 1, you're not changing the value. We are going to change the way it looks, but it's going to have the same value because we're multiplying by 1. When you multiply across the bottom, square root of 4 becomes 2. Multiply across the top, remember outside numbers, inside numbers, and that just becomes 1 radical 2. I'm just going to write it as radical 2. Okay, first one is always weird. Let's take a look at the second one. So this guy over here, radical 2, so we are going to multiply by that radical 2. Radical 2 times radical 2 is radical 4. Square root of 4 is 2. Remember, whenever we multiply something times itself, that is the number, one of them, that comes out. Just a plain old 2. Whatever I do in the denominator, I have to do in the numerator because now I'm multiplying times 1. The denominator is fixed. I'm going to go across the numerator, multiply outside numbers, inside numbers. That is my fraction. So I've gotten rid of the denominator radical, but when I look at this, I always have to try to simplify before I move on, and I see I have outside numbers that will simplify. 2 goes into both. Final answer here is 3 radical 2 because the 2 cancels with the 6. Okay, moving on to number 3. Okay, so now for this guy right here, we have this radical 3. The problem, I have to multiply times radical 3. You can go ahead and just do this. Remember radical 3 times if you multiply inside, that's the square root of 9, and the square root of 9 is just 3. Just take that number out because you have 2 of them, so it's 3 squared. Take out a 3. Now you're going to multiply across the top. Outside numbers, inside numbers, and then we always look to see if we can simplify. We never simplify an inside number and an outside number. Only the outside numbers together. And if there, of course, were inside numbers like we saw there. So you can't reduce the 6 and the 3 at all. But the 9 and the 3 we can. So final answer is 3 radical 6. Here's number 4. Okay. For this guy, okay, like we said up above, we can simplify outside numbers and we can simplify inside numbers. Let's go for it. When I simplify my outside numbers, I can reduce by 2. So that will become 1 over 5. When I simplify my inside numbers, I can reduce, also by 2. Square root of 1, and down here that's radical 3. Well, look at this. Square root of 1 is 1. 1 times 1. Okay, so this here is essentially just 1. Fine. Now, look at your denominator. You have 5 radical 3. This is the first example that we're seeing right now where there is a number times a radical. But let's remember, the problem is when there is a radical in the denominator, not a number, like 5, just the radical. So only when we rationalize, focus on the radical. So here, just multiply top and bottom by the radical 3. When we multiply across the bottom, remember this turns into a 3, but you have a 5 sitting here. 5 times 3, 15. Multiply across the top. 1 times anything is that anything, so it's radical 3 over 15. Okay, so that's one way that we can do this. That's the better way, simplify first. But for those of you who are thinking, you know what if I didn't simplify first? What if I kept this as 2 radical 2 and 10 radical 6? And what if I chose to rationalize this guy first? Well, you have to remember that you're only going to do the radical part. This here turns into a 6. So 10 times 6 in your denominator would become 60. Your numerator, multiply outside numbers and inside numbers, radical 12. I'm going to leave this for a moment. Okay, 2. Okay, radical 12. Radical 12, hopefully you could do that in your head. That's 2 radical 3. 2 times 2 becomes 4 radical 3, all over 60. 4 and 60 reduce. 4 goes into this 15 times, and that's radical 3 over 15. And of course, you could have simplified a little bit earlier. You could have had 1 over 30 and then divided that way. So however you want to do it, it doesn't matter because you're going to get the same answer. Whichever way you do it. As long as you do all legal moves, you got this.